Okay, so this video is going to be 2 examples where your directions would be to find all real zeros. So this would be the process you're going to go through when I ask you to find all of the real zeros, okay? And the zeros are where the graph crosses the x-axis. Okay, so I'm looking for all those places where the graph crosses the x-axis, okay? Now, you need to remember that real can be rational or irrational solutions, okay? Meaning I could have some square roots, okay? So we're just going to get right into my first example. This will be the process you will have to go through when you're asked to find all the real zeros. So, number 1, f of x is equal to 2x cubed plus 3x squared minus 8x plus 3. Okay, so remember that this is going to have at most 3 real zeros. Okay, at most 3. And we're going to start with our first test. We need to narrow this down. And that's going to be Descartes' rule of signs. Okay, remember that means I am looking at how many times the sign is changing in my function. So here, I go from positive, positive, so that's not a change. Positive, negative, there's 1 change. Negative, positive, there are 2 changes. So my positive zeros are 2 or 0. So I'm either going to have 2 positive solutions or no positive solutions. Then what about negative zeros? Remember, this is the one where I do f of negative x. So that's going to be 2 times negative x cubed plus 3 times negative x squared plus, minus, I'm getting ahead of myself, 8 times the negative x plus 3. Okay, so I changed all of my x's to opposite sides. Negative x cubed is going to stay a negative. Negative x squared is going to be positive. Negative 8 times a negative x would change that to a plus. Okay, plus 3. Now I can count my sign changes. So I think the only one happens from negative 2x cubed to positive 3x squared. So we only have 1 negative 0. So from this I know I'm either going to have 2 or no positive zeros and 1 negative 0. Okay? I'm going to do our second test that we talked about today. That would be the rational zeros test. And again, notice that's rational. This only helps us to figure out the rational zeros, okay? And remember, we start with our very last number, constant, factors of that. So we would have factors of 3 over factors of our largest term's coefficient, so factors of 2. So this one's pretty easy because factors of 3, plus and minus 1, and plus and minus 3. And then we would have plus and minus 1 again, and plus and minus 2. Okay, so my possible factors, remember I'm going to go and take each thing. So possible factors would be plus and minus 1, plus and minus 1/2, plus and minus 3, and plus and minus 3/2. Okay, now this is the new part. Now that I know one of my rational zeros is going to be one of these numbers, I'm going to graph it. So, on your graphing calculator, go ahead and get that out while we're doing this. I'll give you a second to do that. Go ahead and put in your original function. So make sure you go all the way back up here. 2x cubed plus 3x squared minus 8x plus 3. Okay, now we're going to hit graph, and what we're doing is we're trying to find where this crosses the x-axis. So, where does this cross the x-axis? You can use your trace to find that, okay, and if I trace over to this one, my calculator says it's about negative 2.97. So it's about negative 3. If I wanted to double check that I was right, I could also go to the table. And my table is way in the 40s. Sorry, I'm going to scroll. So you're in your table, and we're going to try to scroll to negative 3. And if I go to negative 3, notice my y is 0. Okay? Now, which other solution do we have? So go back to your graph. And if you look, I also have 1 as a solution. Okay? I can check that in my table again. So 1 and 3 are my solution, or excuse me, negative 3 and 1 are my solutions from my calculator. So down here, where we said graph it, we're going to say negative 3 is a 0, 1 is a 0. Okay, now that I know that, we're going to use synthetic division because you do not, unfortunately, know how to factor this function, and that's what I'm trying to figure out is all of the factors or solutions of that function. So after graph it, we're to our fourth step here. We're going to use, and I'm going to use synthetic division. And I think for my synthetic division that negative 3 is going to be my factor. Now, why am I doing synthetic division? Synthetic division allows me to reduce the degree of my polynomial. And I want to reduce the degree of my polynomial because if I can get it to a quadratic, then I can either solve it by factoring or quadratic formula. So let's go ahead and do synthetic division. And you've talked about synthetic division before, so maybe you want to pause it and see if you can do synthetic division. Remember, with synthetic division, you add on the way down, multiply diagonally. I end up with 0 here, which is what I want because that means that x minus 3 is, or excuse me, negative 3 is a factor. Now, is a solution. Now, if negative 3 is a 0, then the factor that matches that is x plus 3. From my synthetic division, what do I have left? (2x squared minus 3x plus 1). Okay? Just went through, remember this is your constant x term, x squared term. Now, I need to go ahead and this is a quadratic that I can either factor or use quadratic formula. Okay? So remember, you want factors of 2 that would add to get -3 x. I think it would be that. Excuse me. Now I'm going to factor by grouping. So out of that first term, first two times I take a 2x minus 1. Then minus, those only have a 1 in common, x minus 1. Okay, so my factors are x plus 3, 2x minus 1, and x minus 1. And that is that original third degree polynomial factored. Now, they weren't asking for a factored form. They were asking for the zeros. So we have one last step to do. Okay, and that is set each of my factors equal to 0 and then solve to find the solution. So, I think this one is x equals 1, x equals 1/2, and x equals -3. Okay, so you had, it's about 5 steps by the time all is said and done. Okay, you have to start with Descartes' rule of signs. Then I know what to look for on my graph. Then I have to do the rational zeros test, which gives me even more to look for on my graph. Then I actually go ahead and graph it. Then I went ahead and used synthetic division. And remember, we're doing that to reduce the degree of our polynomial until we get a 2 or a quadratic. So, because that's something we know how to deal with. And then the last step is to actually either factor your quadratic or use quadratic formula. Okay? So what I'm going to do right now is I'm going to give you the second example. And I want you to go through all of the steps with the second example. And I want you to come to class tomorrow with a second example completed. So follow what we just did so I can see how you did. Okay, so f of x is equal to 10x cubed minus 15x squared minus 16x plus 12. So go through all of the things we just did and find all of the zeros of that polynomial.